maximum number of prime implicants. So direct question. So maximum number of prime implicants is 2 raised to power n minus 1. R prime. So if I a K map, suppose like this is a suppose I am writing here 1 1. So here prime implicants basically when we are combining these ones and rectangular join or a square join, like whenever we are making a like a pair, this is pair, a quad, or 8 numbers together. So basically that is combination. So here we can see how many pairs. This pair, and this 3 pairs, right? 3 pairs we can see. So these are only on the prime implicants. 1, 2, and 3. These are 3 prime implicants. These 3 pairs are your prime implicants. 1 and 1 joined together. What is essential prime implicant? Essential prime implicant. Now if you check for essential prime implicants, now here, one and this one is covered. This one and this one is covered when I am making a square combination like this. Right. When they both are covered and this one is when we cover all the ones by using prime implicants, so there is they will become essential prime implicants. This is unnecessary. Number 2, pair is not needed because all the ones are completed. All ones are as simple as that, right? So these are essential prime. One. So prime implicants can be quad and this is number 1, 2, quad and a pair. So these both are prime implicants as well as essential prime implicants. Can be equal also. I am making also. Now here, this one you have to make pair. Okay, because if a pair is possible, make a pair. Quad is possible, quad. The octa is possible. Okay, so you have to make the maximum number of combinations that is possible. You cannot keep it like this one. I'll take it second. No, this one is possible. So this will be third. So this is also a prime implicant as well as essential prime implicant because you are using it. Now this one, if I am right, so it will become a quad. Or you can find out prime implicant as well as the essential prime implicant. A Boolean WI is given. So what you have to do is just solve it, but this is very big expression. Phase 2, what is the K-map? Because it is already a 4 variable, solving it by Boolean algebra will be a quite lengthy time taking process. Draw the K. This is WX is Z. How we right? First term, it is WY. Where is W? So W is there at 2. Okay. So W is positive for this whole block. This whole W is 1 for this block. Now the other term attached to it is Y. Y is positive in, Y is positive here, Y is positive here. So the common and overlapping region, so here 1, 1, 1. Similar way, X and Y. So X is positive here and here, and Y is positive here and here. So it will be 1, 1, 1 and 1. Written it. Next one is W bar X, Y, Z. So it is W bar X, Y and Z. One, it is right. Second, third is done. Now fourth term. Fourth term is W bar X bar Y. W bar X bar, Y is positive here and Y is positive here. Next term is X and Z. X is here, like this. Other term is Z. Z is positive here. So here ones are already there. Last term is X bar Y bar Z. X bar Y bar Z. Y bar Z bar is this. So X bar is at which position? X bar is position and 1. Now you have to make the largest number of combination possible out of this. So we will be making it first. You can see the oct here. Number 1, very easy. Quad here, very easy. But there is one quad here, not easily seen, but it is there. When all the corners are ones mapped, so that is also making a quad. Quad number 3. So these are the essential prime implicants. Right? There can be many prime implicants from this, but essential prime implicants are these only. Function minus x, y. Prime implicant can be, this is also prime quad, this is pair, but essential prime implicants means maximum. Okay, so making this quad first. So quad is equal to, that is y is common. So y, sorry, octa. Octa is y, and making quad number 2. So quad number 2 will be x common and so here x is common and other term is z is common. The last quad, in the last quad x bar is common, and this is right option. Yeah, right option. So that was our right option. So y, x, z, x bar, z bar, or right option. Moving on to the next question. In expression y x plus x y bar plus x whole bar will be simplified to what? Is x plus y bar plus y bar it will be x plus x y bar plus xy, y into y bar will be equal to 0. Erased. So here move this bar from the top, so that will be y bar bar r bar x common, that will be 1 plus y bar and so on remaining. So here we can see 1 added to any, that will result, this whole will result into 1. 4 and 5. Values 0, 1, 2 are the prime implications. See 1 x y will become 0. So this is x bar. Here this is complement, so which is common, y, and y is bar. Here x is 1, x and is common, y bar. Your prime implication. One, you have that big expression, and you have to find out the relation, whatever the option is. I just find out. So the given value is x so x y bar z bar. We have to put x is equals to 1. X is equals to 1. So 1 plus anything, completely brackets, plus anything will become 1. And 1 multiplied with anything will become that thing only. If I 1 with that is that like that expression. 1 multiplied a, that will be a only. But 1 plus, this is how Boolean expression works. 1 plus a is equals to 1. A multiplied by 1 is equals to a. Right? To multiply 0 with anything, that will become 0. And to add 0 to anything, very simple. Now x bar, so basically 1 bar, so that will be 0 plus z bar, 1 plus y. This whole equal to 1. So here 1 plus y will be 1. The term will be bar equal to 1. Z will be your correct answer. Okay, great. Moving to the next question, says that there is the Boolean expression given. You have to minimize it. So minimize it have to by using your Boolean algebra or by making star. The best way to do it is by K-map. So this length. Otherwise, you have to common this, and then that is a time taking. That meantime, you can easily so finding out the mean common term. Okay, a bar right. A bar, B bar, C bar, B bar B 1 A bar A B bar D A B bar and bar. Now you can see very distinct numbers present, but here there is a pair hidden. This pair is this pair, because these two are distinct. Pair is making no other term. You can write it as it is. Pair will be expressed. Pair will become B bar is common and bar a term as it is. A B bar plus option satisfies it. Or C option. Otherwise, you could have this is, but that became easy when solved the K bar. Right? After solving the easily see B bar C bar and D, right? By taking the common term, but that otherwise you have to solve the term, all the common. But this practice in all a lot. Great. Moving on. Next question. Start the Boolean y is equals to AB plus CD. So we realized by put an AND gate, the minimum number of gate required should be. Minimum number of gate required in order. Now you see the OR gate, and this is the these. For this we take AND gate. Start least more input we. So this is gonna give me AB bar, AB bar. Now I have to OR CD bar. Now I have to OR them up. OR them up. So inverted AND gate OR gate. I do inverted OR gate. I do this. This is gonna get what? So invert this AB plus C. And if you don't understand this, if I draw a NAND gate only, NAND gate will do what? AB the whole bar like this. AB whole bar AB. How many number of gates will be required? 1, 2, 3. Write down. Okay. Next question. The Boolean table. There is some table. Find out whenever you were getting equals to, you are getting D is equal to A bar plus A. This is you are getting it. B common will be A bar C plus. There is no option written like what into that, but which you can find out. So I'm taking B common, will be A bar C bar. Now this is what? XOR only. And if we write it in terms of XOR, in terms of OS, it will be A plus C, A bar plus C. Option number, that was B bar here. Our answer was the answer. Basically, they were asking this, but the options were not given in pattern. The expression A plus B. Best way to find it out is by came up. DC bar. Then the solve it by an expression also. Plus AC plus B bar plus A bar, expanding it bar, so it will be ABC plus AB bar C bar plus bar. Option is matching, so I know this option is like correct, but we have, let's just see where are the men and C. AB bar C, so A bar, last one are B bar. How we will put way, that will be A bar A bar C is okay. This is okay. B bar is this is one. This is also not A C. So A and C. Okay, this is B C bar. B. This is also there. Okay. B bar. B bar. C stop.